This website will help you with understanding a little bit of covariation. And so we have this wonderful crab up here, and we have the length of how they're going to walk across this. So I just want you to visualize what happens in terms of just thinking about how this graph might be created. Thinking about, so covariation is co, meaning that there's things happening at the same time. In this case, we're looking at things happening along the horizontal axis and vertical axis at the same time. But we're going to keep that all in reference to what the crab's doing up at the top. So if I just push play here, you can see the crab is going slowly and then speeds up. And then over here, he's just hanging out over this time. So if we notice, speeds up and then just stays stationary about 10.5 inches if we're using this as an inch. But if we watch him one more time, he starts, and then about at 5 inches, if we want to call this inches, he speeds up. Okay, so now I'm going to pause this. Let's move this back over to where the crab's going to start. And this time I'm going to click on the time, and notice that we have a finger pointing here, and so this finger is going to keep track of time, and time's going to move along the horizontal axis. So when I push play again, and you watch the crab move, and the hand move at the same time, you'll see what's happening with time. And again, time is just moving along, and it never changes. It doesn't notice the crab sped up his walking or his moving along, but the time remained at this constant speed, just the time moving along, and then it starts over again. So when I pause, I'm going to deselect the time, and this time I'm going to select the distance from start. So now we're tracking the distance the crab is moving from the start, so from that 0 point right there. And so this time we're going to use our left finger, and we're going to follow along the vertical axis. So watching the crab and watching the finger, watch what happens as the crab moves and the finger moves along with it. Okay, again, this is distance from start, so the distance is increasing, and then the distance moves really fast, and then the distance holds steady. So now we're going to put the two things together, and we're going to watch both fingers happen at the same time. This is covariation. So both fingers are on the point of origin, and then we're going to watch both fingers move in unison. This is what we consider covariation. Watching two variables move or covary, changing at the same time. So one last thing, we are going to try and track this now, not with our independent fingers, but one finger is going to track the movements, keeping in mind where these other two fingers are going. So I'm going to display this once. And so you kind of have a visualization of how that graph is going to look. But now I'm going to put both fingers, start again, and our left finger, right finger is along the horizontal axis, left finger along the vertical axis, and what this middle finger, if you will, is doing is tracing along above where each one of these would be represented. One last piece to this is we're going to throw on the fairy dust so we can actually trace what's going on. And that would be the graph of what's happening in this covariation model. So we're going to refer back to this idea of covariation throughout this particular course, and keeping in mind that covariation is when you take two variables and you find out what's happening at the same moment as one is affecting the other.